Welcome students, this is Charan Singh Negi. In previous sessions we have some problems which is related to the limits, and today we are going to solve another problems of the same kind of the limit. Here we are going to discuss the trigonometric functions. See, that is the first problem which we have. This is x tends to 0 sin ax upon bx. So now the solution of question number 1, that is limit x tends to 0 sin ax upon bx, right? So we know that is if I put this as value, this is sin a into 0 divided by b into 0. That is the angle which is multiplied. This is ax's angle. So this is sin 0 upon 0. That is sin 0 is 0 upon 0. This is undefined form, right? Undetermined form. So we have to remove this undetermined form and to solve the problem. So this implies that we just writing this is limit x tends to 0 sin ax upon, we have to write this is ax, right? So that it becomes 1 and into this is limit right, this is the value x tends to 0 into if I multiply this ax to the denominator of this function, then we have to multiply it to numerator also. This is numerator divided by bx. Here we know that this is limit theta tends to 0 sin theta upon theta is equal to 1. Here we have to use maximum times this identity, this rule. Now this is x cancel out, and we know that this is equal to 1. This whole is equal to 1 and this is 1, right? 1 into this is a limit x tends to 0 a upon b. So this is equal to a upon b. Because there is no x on here in this term, we can put the value x is equal to 0 where? Nowhere, right? So that the solution is a upon b. Now see this one, the same kind of problems we have, the second one. Now check this is here the solution number 2, this is limit x tends to 0 sin ax upon sin bx, right? This is equal to, if I put the value of x is equal to 0, this is sin a 0 upon sin b into 0. So that is equal to sin 0 upon sin 0, and this is 0 by 0 point. This is again undetermined form. So we have to remove this undetermined form to under mathematical process, right? So now see, this is just writing this limit x tends to 0. This is sin ax upon sin bx. All right. First, this is, we know that that is the rules of limits, where we can introduce the limits on the numerator on the numerator as well as in denominator. I'll just provide you this is limit x tends to 0 sin ax upon limit x tends to 0 sin bx. Right? Now we have to make it is 1. So how to make it is 1? By dividing by ax, and this one the denominator becomes 1 by dividing by bx. Okay, see, let's check this one. So now this is limit x tends to 0. This is sin ax upon ax, right? This is sin ax upon ax and has to be multiplied because we have divided this one by ax. So we have to multiply it by the same as ax, right? Limit again, this is x tends to 0 sin bx, and we have to divide it by bx, then multiply by bx, so that mathematical concept will not change. If I divide it and multiply the same thing, this is 1, and we can divide or multiply by 1 any function. Okay, see, so now let this is x cancel out, and this is 1, this is whole is 1, this is 1 into a divided by this is whole into 1, this is 1 into b. The same also, that's what we get, this is a upon b. right? So that is the solutions. This is a upon b of the second part. So such type of trigonometric functions, first we have to check it whether it is in 0 by 0 form or any number divided by 0 form, and then we have to remove this one by under mathematical process. If it is a trigonometric function, so whether we use the we break or we use the sine theta upon theta is 1. Right? Thank you, students. Thank you. In the next sessions we will solve some more problems. Thank you.